Hello everyone, welcome to the next training tutorial in which we are going to dive into some more features of Java 8, specifically Lambda expressions. We would see list, we would see streams, filtering stream, find first element of the stream. We would also see method references. We would see what are intermediate and terminal operations. And at the end, we would see how WebDriver can be used to carry out these different operations when using list. So let's get started. By the way, if you're just starting with Java and Selenium, then this is not the right tutorial for you. I would link my training programs on the description of this video. So you should start from the beginning and not here. All right, so let's get started. So we have all worked with list in past, and we would see how list operations are optimized in terms of using Lambda with Java 8. So I have a very simple example here wherein I have a list which contains some elements, some integer elements from 1 to 9. And what I'm doing is I get first even number which is greater than 4. And this is a list operation without using Java 8. So how would we do this? We would iterate through a list using for each loop. So this is a for each loop. We declare an integer here, and right inside we have the list which is to be iterated through. And then we know how we can find out even number, and we also know how we can find out something which is greater than 4. So what we do here inside a for loop, we have a condition if I is greater than 4, and if I divided by 2 gives us 0, which means if I is, well, obviously greater than 4, and if I is an even number, then we just store this in a result variable, and then we break the loop, and in the end we print this. Let me comment out rest of the section and let me run it and show you how it is. So if I run this, we should get first number which is greater than 4 and is even number. So we know that in this list this is 6 because 6 is greater than 4, as well as an even number. So let me run it. Yep, so we got 6 here, which is no rocket science. Now let's see how this could be done using Lambda. So I'm going to bring back this section now. In case of Lambda, what we do here is we iterate through the list, but we iterate through the list using something called a stream. So with the Java 8, we have we have a stream method on the collection API, and using this method we can get the stream. For now, you can assume a stream as a sort of iterator, like the iterator which we have seen in past when iterating through a list or any other collection. And here in Java 8 we have some sort of fancy iterator which is known as a stream, and using this iterator we can carry out different operations on the list. So we get the iterator on the list using stream method, and then once we have the stream API, then we can invoke the methods on the stream API. Now there are different methods on a stream API, and one of the method is filter. As its name indicates, the filter method is used to filter the elements on the stream on a given criteria, and we have two criteria here. One is the number should be greater than 4. So what we do in the filter is we write I arrow I greater than 4. You must remember this from the previous session, that filter takes for example a predicate which is a functional interface, and being functional interface, it has just one abstract method which is test, and it takes one argument. So what we discussed on the previous session was that whenever we have a functional interface and we have an abstract method which takes one argument, then the implementation goes like this. On the left hand side of the arrow we have the argument, and on the right hand side we have the implementation. So the filter method is going to take the predicate here. This is nothing but the implementation of the predicate here, which is the apply method. So the argument for the apply method goes on the left hand side and the implementation is on the right hand side. So it takes element of list here, which is stored in variable I, and compares whether it is greater than 4 or not. So this becomes our first condition to filter out numbers which are greater than 4. And then we have another condition, which is number should be an even number, so we filter it again. So if you see here, filter gives us back stream, so we can again apply the APIs of a stream on what we get back from filtered stream. So we apply another filter here, and here we say I divisible by 2 equal to 0, which means that a number is the even number. And then what we do is we call another method on stream, which is find first. So what it would get us, it would give us something called an optional, which is another API added on Java 8. This is not visible here, so let me close a couple of yep, it's available. Yes, it's right here. Yes. So this is again an API on stream interface on Java 8, and what it would give us, it would give us optional. It would give us optional here, or we are targeting optional here, because it may happen that our list does not satisfy this condition at all. And if that happens, that we don't want to get, say, for example, null pointer exception and get stuck with such errors. So we get an optional, and then there are checks which could be performed on optional. I'm not performing those checks here for the sake of simplicity, but let's just see this as we are getting the first optional element which would be retrieved as part of these operations after filtering. And then what we do, we call get API of the optional class, and get is going to give us the value of the optional. So this is actually same as the previous example, but here we have carried out all of the operations using lambda operations in Java 8. So now if I run the main method again, then we would get 6 again. Yep, so first one was without lambda, and the second is with lambda, and we get 6 again here. So we have a list which is a stream through, then it is filtered on numbers greater than 4, then it is filtered again on numbers which are even, then we get the first optional element, and then we get its value. That's all simple. Let's see what we have to look at next. So next we would see how method references can be used with this. So let me open a different class here, which is trial class. Let's keep other one also open. Maybe we do some comparisons. So in the trial class, what I have is I have the same syntax here. I have the main method here. I have a list here, list of some elements, and then we are going to get we are going to run through this code and see what is different here. So if you compare with the previous example, in the previous example we have filtering, and then we have our implementation mentioned right here. So this is the lambda, this is the implementation of predicate here. So filter takes predicate, and this is the implementation of predicate here. But what we can do is, we can take this logic outside filter, because at this point of time this is quite easy to understand, but you would come across logic which gets complicated with double braces and so on, and in this case we should abstract it out in a different more readable method, and this is what is happening in the trial class. So it's the same filter API here, and here I have declared a method called is greater than 4, and what this method does is, well, nothing great. It takes one element and then it finds out whether this element is greater than 4 or not, and this element is then retrieved here. In the similar way, earlier what we were doing is we were checking the evenness of the number within filter, but here we have created another API which is known as isEven. So isEven is also quite simple. It's doing the same thing like before. We are dividing the number by 2 and see whether we get 0 or not. So this is about filtering the even numbers, then rest of the syntax remains same. We say find first and get. Now let me comment out rest of the code so we see what's going on with this. What goes when we execute this? Well, the results should be same, so let's run this. Yep. So we have some print statements happening. We will have a look at them later on, but right now let's just focus on what final result we have, and the final result is the 6. So 6 is our value, which is greater than 4 as well as an even number. But if you pay close attention to implementation here, you see, this line is sort of highlighted and the other line is also highlighted. So what Lambda or compiler is trying to tell us is that we can use something called method references. Now let us see what are method references. So let me comment this out and take this section out, and let's comment this out. So let's see what we can do here. Now, as you see here that these are static methods declared in this class, and there is actually no logic happening in these in the argument list as such here. So what we can do is we can as well just replace this with a different syntax. We can say filter name of the class, two colons, and name of the static method. And this is method reference. This is one type of method reference. There are constructor method reference and some other ways to have method references, but let's see one simple example of static method reference. So what we do here is we have the class name, two colons, followed by the method name. In the similar way, we are having another instance of method reference in the next line, which is to call isEven method. How? We have the class name, two colons, and isEven method. Rest of the code remains same. We had find first here, we have find first here also. Now if you look at this closely, we have a method reference or in this statement we have a function being called, which actually itself is invoking another function, and this is known as higher order function. Now, how is method reference possible here? Because we are not having any other operation happening in terms of what we get from the list and what we give out. We filter it, of course, but we do not make any modifications in the value of the list itself, and this is why we are able to use the method reference. Now there are some more pointers to notice here, because if you had a close look at last one, you saw lots of not this one. Yes, this one. We had lots of other statements being printed, and we would see what was happening there. So what compiler does with the lambda expressions is it's not going to invoke every operations until unless we really have a terminal operations being invoked. So this brings us to our next topic, which is what is terminal operations and what are intermediary operations. So operations like filter, which do not make any modifications on the list per se, they are known as intermediary operations, and the final operation which is going to get us the result is known as terminal operation. And as long as terminal operation is not invoked, we would not see operations being carried out on rest of the list, or we would not see these intermediate operations really happening. So for example, if I comment this section, and if I could show you the next one, which is this. Yep. So this is the next operation. So have a look here. What we are doing here is we have some print statements, then again we have a stream over the list, then we are filtering is greater than 4 and is even, but we are not collecting the elements here, or we are not calling any terminal operations, for example find first. So what we should see when we run it, let's try that. So it printed the line here, which we have here, remove terminal operations, and no intermediate operation is carried out. And this is what you see here. Even though we have print statements in is greater than 4 and is even, we see them not being printed here because the terminal operation is not called, and until unless terminal operation is not called, we would not see these operations being invoked. So this is the sort of advantage of lambda intermediary and terminal operations, that until unless terminal operation is invoked, we would not have real exercise being carried out. Now let me comment this out again, and let me show you the previous set once again, which talks about filtering using method references. So we have method references here, and let me run this line again and show you the output. Yep. Now let us notice something was being printed. So first we have the filter here with is greater than 4, so the check goes here, or the control goes here, and then we have the check happening here which says is greater than 4, first time 1, then 2, then 3, then 4, which was not greater than 4, and then we have 5, and 5 is greater than 4, and only after that we have second filter being invoked, which is even. So then control goes here, and then is even is called here, and then it checks, well, is 5 even? Well, 5 is not even. Then it goes to the next element in the list, and then we have 6 here. So is 6 greater than 4? Yes, 6 is greater than 4. And then control goes to is even, and then it checks whether 6 is an even number, which is an even number, and this is how we get 6 printed. What I'm trying to highlight here is that if you see, out of these two filter operations, the second filter to check the evenness of a number is not called until unless first filter is satisfied. For example, we do not have evenness being checked in any of these numbers until unless we reach a number which is greater than 4. And this is the advantage here of having this sort of lazy invocation, that an operation is invoked only when it is required and not before that. Pretty interesting, isn't it? All right, let's see what else we have in this class. Yes, I have some more operations here. Let's check what's happening here. So here I have another method on which we have filtering performed. This is with some more logic. So what we are doing here is a simple method which takes a number, and again it just checks whether it is even or not. However, what we have done here is we have performed a multiplication operations over this number. So we are multiplying this with 5. And now if you notice, the compiler is not going to prompt us to change this into the method reference. So if I comment out the first section, you see here we have compiler asking us, this could be converted into method reference, but now this one could not be converted to method reference, because what we are doing is we are sort of modifying what is being given to the filter here, and this is why method reference is not possible. Let's see what we have next. So we have seen terminal operations, we have seen intermediate operations. Yeah, let us see WebDriver and list example, the most important thing. So I have a new class here called Selenium with Java 8 session 2. I'm going to commit all of this to my GitHub account, and I would link this on the description of the video so you can find it. Now let's see what's happening in this class. So we have our usual registration page, and I have added a method on registration page to get all links, which is a CSS selector. And then what we do is we need to get the link count. We need to get the link count containing text Selenium without lambda. I should drink some water. Now let's carry out this operation without Java 8, without lambda. So the task is to get link count for all the elements which contain vertex. And how would we do this without lambda or without Java 8? Well, we would declare a new list called resultant list, and then what we would do, we would iterate through the existing list using for each loop here. So we have web element iterating through all of the input elements, and then we find out whether text contains Selenium or not. If it contains Selenium, then we add it to the resultant list. In the end, what we do, we print the size of the list. Very simple, nothing new. We have done this many times. So let me run it. I need to change the config here. Oops, not this. I need to change the config here to make it use testng. So let me change this here, testng XML. Okay, yep. So let me run this now, and let's get the count of elements which contain the word Selenium. Very simple form. And it's over. Let's see what we have here. Yep, so looks like there is just one element which contains the word Selenium on the page. Now let's convert this into Java 8 and see how that works. So let me comment out this section. So in Java 8, we know that we can iterate through using the stream, which we saw a while ago. So what we would do, we would start creating stream on this input element. So this is what I have done here. I said input dot stream, and then I filter out the element here. How I filter out the element? Well, we have to filter out the elements for the elements which contain the text Selenium. So I say filter as again the variable or the argument for the method goes on the left hand side and implementation goes on the right hand side. And what is the implementation here is quite simple. The same thing what we had here is the implementation. So we have element dot get text to lowercase contains Selenium, and then it would filter it out for us. And then I'm using a method called count, which is another API on the stream, which gives us the count of the number of elements. Very simple. So instead of writing this whole jumbo for loop, we can use a stream, filter the elements, and get the count. So let me comment out this section and let me run the one containing lambda in Java 8. Let's see what happens. We should get the same count we got before. Okay, it failed. It failed because of null pointer exception. I got null pointer exception. Let me see the error. Okay, why did it get me? It got me null pointer exception because I should have started the run using the test.ng XML. So let me set this again. This is not right. I will change it to all in package suite. Yes, that's right. And that's my suite test.ng XML. Let me set this. Okay, let's run it now. So we have browser invoked here. Again, we have check happening on the links containing word Selenium. I have only one search word on my blog, so we should get the same result again. So we get the count as 1 here too. So this was the outcome of converting the old Java 8 style code to, old non-Java 8 style code to the Java 8 style code. Now let's try to do something more on this. So I would remove this and put it here. Now, if you see what was happening here is, we have this whole logic happening within the print statement, and what I have done in the next set of lines is I have taken it outside. I have created a different method which is going to get us the link count for the given word, and it takes a list and it takes the word on which you want to perform the search. And let's see the implementation of this. Well, implementation is the same what we have seen before. So we have the list here, we get the stream on this, then we filter out the elements, and then we count. What I have done here is, in comparison to the previous filter, I have created another method. So I'm not having this entire syntax written over here. This is how it was before. I should replace this with s. So this is how it was before, but it's still quite easy to understand. But over a period of time, you would see more and more complicated logic on filters, and you should abstract it out in more comprehensible methods. So this is what I have abstracted out here in a different method called hasGivenWord, and this takes, well, element and the word on which we have to perform the check. So we do element dot, which is web element dot get text to lowercase and contains. So logic wise, there is not much difference in this set of operation than what we were doing before. It's just that we have abstracted out the operations in a different method for us to get the input elements containing word Selenium. So let's run it too. Browser is launched. Count is happening on the links containing word Selenium. And let's see, our test is green. Yep, and again we have just one link. Now let's move next and see what's happening in next set of lines. So this is next set of system. Let's comment it out. Not here, here. Okay, so I need to get this variable. This variable is missed out with my commenting. Yep, so I would declare it outside so we have access to this. Okay, great. So the error is gone. Yeah, Java is complaining that I don't have to initialize it anymore here, but that's okay. So resultant list. So let's see what's happening here. Now we are complicating our mechanism a bit. So far we are getting the links containing a specific text, but now we also want to get only those links where word length is greater than 4. And what we are doing first, we are trying to carry out these operations without lambda. How would we do this without lambda? The similar way, we would create a new list, and then we would iterate through the existing list, which is here, input elements, get all links, and then we say, okay, get me the text of this link and convert it to lowercase, get it into a variable called word, and now perform the check whether it contains word test and the length of the word is greater than 4. If that is the case, then we store this in new resultant list. Once again, if the element contains word test and the word length is, as a number of characters in the word, is greater than 4, then we store it in our resultant list. So this would give us a new list containing word test and the word length is greater than 4. And then what we do, we want to print all of these text. So now we have a new list. We can iterate through this new list and print all of these elements. How we do that? Well, we know the for each loop. Simple. Get the web element here, and from the web element we can get the text and print all of these elements. So let's run it and see what happens. Again, browser is launched, count is happening, just that we have a bit more logic here. And browser is closed. Let's go back and see what is printed here. So you see here, we get the list containing 4 elements here, and then there's a print happened on all of these elements which contain the word test. So here we have test, here we have test, here we have test, here we have test, and each of this line contains more than 4 characters. So we have not done anything miraculous here. We just use the existing non-Java 8 operations to carry out this exercise. Now let's change this. Let's do this using Java 8. So let's see what happens in Java 8. You may have guessed it by now that we would have 2 filters here because we have to filter it twice. Once we have to perform the search on the word, and then we also have to check whether the length is greater than 4 or not. So let's see what we can do here. What I have here is the operation in terms of how to get the final list, which is going to satisfy condition of containing word test. So I have stored this in a new list. I have named it list retrieved using lambda. You can name it whatever you like. And then we have input elements. We call a stream on it. So we get the stream and then we start filter operation. Let me bring it here. So what is our first filter operation? Our first filter operation is to get all of the elements which contain word text, and this is what is happening here. Filter element, which is the argument of the predicate here, or the only available abstract method in the predicate, to be more precise. So this goes on the left hand side. We saw this before too. And on the right hand side, we have the implementation. You can as well abstract it out in a different method outside this to make it more comprehensible. So this is our first filter. And then we have next filter, which checks whether the elements which are returned from the first filter, do they have length greater than 4 or not. If so, then what we are doing is we want to collect this in another list. We are creating another list out of this so that we could iterate through this new list. And how we do that? From the last filter, we get the stream, and on the stream, we have an API called collect, using which we can collect different collection objects, be it list, be it set, and so on. So it takes an argument of type collector. And what we are doing here is we are calling something called collectors, which is a sort of util method, which is going to convert this final stream into a list. And this is what we have stored in list retrieved using Lambda. What we do later on is we want to print all of these elements, and we have seen in previous session that on the list we have for each method, and this is what we have invoked here. Again, we are printing these elements using another Lambda invocation, which is print all of the text values of these elements. Simple. For each, which takes consumer. We have seen consumer in the previous session, which is another functional interface. It takes accept method, does not return anything. So here we have argument on the left hand side and the implementation, which is nothing but printing this on the right hand side. As again, we can abstract it out in a common method. So let me run it and see what happens. So the browser is invoked. Count and check on the text length is happening. Browser is closed. This is our run, and you see again we get the list of size 4, and we have 4 elements in this list, and all of them contain word test. So we saw different ways of using list with and without Java 8, and as you can see that with Java 8 using Lambda expression, it reduces boilerplate code to a great extent. Let's see if we are left with something else. Looks like this is all for this session. In the next session, we would see map operations and we would write some more WebDriver examples. This is all for this session, and if you enjoyed watching this session and if you learned something new, then please hit the like button. Thank you. Bye bye. Stay safe.